All right, mathletes, here's a 9.2 solving radical equations. So a big thing with radical equations, we always want to double check our solutions because we're quite often going to get extraneous solutions. By solving radical equations, by squaring things, sometimes we have issues with negative answers not being correct answers. So first step with solving radical equations is you always must isolate your radicals. So get that by itself on one side. For this one, I'm going to have to subtract 2 on both sides. So after I do so, I get the square root of 3x minus 2 is equal to 4. So now that I have it isolated, to undo a square root, I'm going to square both sides. So I'm going to square this, and I'm going to square this. And then here I get 3x minus 2 is equal to 16. Then solve it. Plus 2 plus 2. Get 3x is equal to 18. Divide by 3 and get x is equal to 6. Check my solution here, and I can do 2 plus the square root of 3 times 6 minus 2, and see if that's equal to 6. So working from my radical, this is going to be 18 minus 2 plus 2. 18 minus 2 is 16, so 2 plus the square root of 16, which is 2 plus 4, which is equal to 6. I verified that my solution is correct, and I'm good there. Next one here, I have square root of x minus 3 plus 5 is equal to x. So what happens, I need to isolate my radical. So by doing so, I'm going to get square root of x minus 3 is equal to x minus 5. Now that it's isolated, again, square this side and think it's a whole quantity, so I got to square an entire piece. So doing so, this is just going to leave as x minus 3 here. On this side, I got to double distribute and treat it as x minus 5 times x minus 5. As I double distribute that, I'm going to get x squared minus 5x is minus 10x, then plus 25 is equal to x minus 3. At this point, I recognize I have a quadratic equation. So to solve a quadratic equation, I must set it equal to 0 first. So I'm going to minus x and plus 3 here. So I get 0 is equal to x squared minus 11x. Got my x on the top. And 25 plus 3 is going to be plus 28. So I'm going to try and factor this, and hopefully it will. Otherwise, I could use my quadratic formula or complete the square. So things that multiply to be 28 and add to be negative 11. Well, I'm in luck, I get negative 7 and negative 4. So this becomes negative x minus 7 and x minus 4. So my solutions for x are going to be 4 and 7, potentially. I need to check these for extraneous solutions. So when I plug in 4, so I'm going to check x equals 4, and I'm going to get 4 minus 3 square root plus 5. Is that equal to 4? Question mark. 4 minus 3 is 1. Square root of 1 is 1. Plus 5 is equal to 4. So, no, not equal to. X is not a potential solution. X is an extraneous solution. Notice, if this value here would have been a negative 1, it would have been true. By squaring at this step, we sometimes have issues with getting solutions that aren't correct. So a basic example I can give you is if we have negative 2 is equal to 2, that's not true. But if I square both sides, as I did here, square this, I get 4 is equal to 4, which is a true statement, so I get some kind of solution. Okay, but that's not necessarily accurate because we know that -2 is not equal to 2. So that gives you an idea algebraically why we get values that are extraneous and we aren't solutions after we work it out. Let's go ahead and check our other one here. And so if we have x is equal to 7 and I plug it in and I get square root of 7 minus 3 plus 5, is that equal to 7? 7 minus 3 is going to be 4. So the square root of 4 plus 5 is equal to 7. Well, square root of 4 is 2 plus 5 is 7. That one is going to be a solution. So how does this look out graphically for our extraneous solution? So you can see here's our original equation on the left. If we typed in the left equation into our y equals in our graphing calculator, we would get this radical looking function there. And our graph here, x, is just the line y equals x. So you can see they only have one solution here where x is equal to 7. Okay. Well, when we rearrange things and we got x minus 3 is equal to x minus 5 squared, by doing so, you see that we get two potential equations. So you can see x minus 3 is this line here. And for this x minus 5 squared, quadratic, it's there. So by squaring this, notice it gives rise to two solutions here where they intersect. Well, this 4 did not appear over there, so this is our extraneous solution. This, where x equals 7, was apparent here. So we just always need to make sure we check our answers because it can come up that we get a false positive answer. All right, let's try one more. So sometimes you'll have radicals on both sides. We talked about how 1/2 is the same as a radical. So to solve these, what you want to do is get your radicals each on one side. I'm going to add 2x plus 7 square rooted to the other side. So I'm going to get 3x plus 2 to the 1/2 is equal to 2x plus 7 to the 1/2 here. Well, now I can square both sides to undo my 1/2 power. And then I'm just going to have a linear equation, 3x plus 2 is equal to 2x plus 7. Minus 2x here, minus 2x here, minus 2 there, minus 2 there. And I get x is equal to 5. Again, I want to check for extraneous solutions. So I get, from the left side, I get 3 times 5 plus 2, 1/2. Well, that's going to be 15 plus 2 is going to be 17. So I get square root of 17 on this side. On the right side, I'm going to get 2 times 5 plus 7. Well, that's also, from this to the 1/2, is also being square root of 17. So when I subtract them, yes, it's going to be equal to 0. So yes, x equal 5 is a solution there. All right, that's the end of notes tonight. Go ahead and highlight any questions you have and bring them to class tomorrow.